Hey, welcome back, everybody. Today we have chapter 5, lesson 3. We're going to be talking about dimensional analysis. Dimensional analysis. Now, what in the world is dimensional analysis? I'm glad you asked. We're going to be talking about that today. What in the world are we talking about? All right. So we have four warm-ups to start off with. And what you are going to do is you are going to change these rates into unit rates. Change the rates into unit rates. All right, go. All right, so the very first thing, what I like to do in these situations is, first off, you need to start with a rate. You need to start with a rate to get to your unit rate. So the very first one, you jump rope 192 times in 6 minutes. Well, we are going to take 192 over 6 minutes. Don't forget to have your labels. 192 jumps in 6 minutes. And when I divide that by 6, because I want that bottom number to be 1, remember, my answer is 32 jumps in 1 minute. Okay, 32 jumps per minute. Next one, we have 4 pounds of bananas for $2.36. Now, even though 4 pounds comes first, remember, we always put dollars on top. Dollars is in our numerator. So I take $2. Whoa. What are we doing here? That was an ugly, ugly label. All right, so we have $2.36. We have 4 pounds. And when I convert that, I will divide by 4, and my answer is going to be 59 cents, 0.59, per pound. Not bad. 59 cents per pound. Nice. Next one, we have 16 anchor bolts for $18.56. Again, what does our unit look like, or what does our rate look like? Well, we know we need to have $18.56 on top, okay, and my 16 bolts on bottom. How do you get rid of that 16 on bottom? Well, I have to divide by 16, so my answer is going to be $1.16 per bolt. Okay, $1.16 per bolt. Last but not least, we have 288 movies on 9 shelves. We're going to take that 288 movies, and we want to have movies per shelf, so we have 288 movies over 9 shelves. When you get your unit rate, it's going to end up being 32 movies per shelf. Notice the change in spelling. Okay, so don't forget, you start with a rate, move on to your unit rate. Divide by your denominator. Okay? All right, here we go. What in the world is dimensional analysis? Well, we're going to be learning that today. Keyword right there, we're going to learn. Yay! Okay, we're going to be using one or more conversion factors to solve rate problems. Oh my gosh, Mr. Sheeman, what are you doing? You're using these big words. This is math class. Come on. What is a conversion factor? Well, I'm glad you asked. Here it is. Here it is. So, conversion factor, I want you to pause this and write it down. All right, so when you look at different things, all right, conversion factors is a ratio used to change or convert one unit to another. Okay, this conversion process is called dimensional or unit analysis. You may see dimensional analysis or unit analysis. Oh my goodness, we just explained both things. Awesome. So an example of this would be when you convert feet into inches. How many inches are in each foot? Well, we would use the expression of 1 foot per 12 inches. Okay, feet to miles, we may have 1 mile contains 5,280 feet. Okay, so these different units, we're going to be changing and converting from one unit to the next. And we're going to be using these different things, these different conversion factors in that. Another one could be there are, in 1 hour, we have 60 seconds. Okay, again, we're going to be changing from one thing to another, and we're going to be using these different factors. So the very first thing I want you to do, you're going to find the appropriate factor for each conversion. Now, remember, you are changing these from one thing to the other. If you need to convert different things in your homework, you can use this note sheet to help you. So what I want you to do is you're going to put these into rates. You're going to put these into rates, which means you're going to have different fractions for each. Okay? So put each rate into a fraction. Go. All right. So when you look at this, you got to think to yourself, feet to yards. We're changing feet to yards. All right. If I'm changing feet to yards, again, that word to tells me what goes on top, what goes on bottom. Feet to yards. I have 3 feet in 1 yard. Okay. Pounds to ounces. This may not be as common as the feet to yards, but again, pounds go on top, ounces go on bottom. So if I look at this, there's 1 pound. There's 16 ounces inside each pound. 1 pound, 16 ounces. Look at this. Again, that word to tells me what I'm changing it to. Okay. Then minutes to seconds. How many minutes or how many seconds are in each minute? Well, 1 minute has 60 seconds. Okay. Last but not least, hours to days. How many hours in each day? 24 hours in 1 day. Now, you may be, remember, as you look at this, you may be wondering, okay, do we always have ones go on top or the other number go on top? It all depends on what you're converting it to. So, for instance, at that pounds to ounces, I needed to put pounds on top because that's what the rate asked me to do. Down here, hours to days, I put 24 on top, the bigger number on top, because I'm changing hours to days. I have hours comes first, days comes second. So it all depends on what you're changing different things to. All right? So let's try a problem. So the very first thing we're going to look at, it says the average American uses 580 pounds of paper per year. Holy buckaroos. Okay? How many pounds of paper does the average American use per month? Okay, so now we're changing different things. And how we do that is we use our conversion factors. We're going to be converting different things. All right? So if I look at this, I'm going to set it up, and we're going to do this problem together. And this might be easy, but I want you to start using a process that I'm using, because you're going to see this process a lot when you get older and start getting into like your chemistry. A lot of times they use these. Physics uses this process, and of course our algebra and later on in math, Algebra 2 uses these processes as well. So we are going to use this same thing. Very first thing I want to do is I want to put the 580 pounds of paper per year as a rate. So how could I put 580 pounds of paper per year in a rate? Well, I take 580 pounds of paper. Okay, I'm just going to do 580 pounds over 1 year. We want to convert this into months. And what I like to do is I like to let our labels tell me where they need to go. All right? I want my labels to tell me where it needs to go. Okay? So for instance, I want to change this word year. Okay? I need to change that to months. Okay? I need to change years to months. Years to months. Okay? How do I change years to months? Well, how many months are in each year? Well, since years comes first, I have 1 year in 12 months. Okay? 1 year in 12 months. Now what this does, okay, by putting years on top, just like a fraction, when you have a common factor with your fractions, you can cancel things out. For instance, if you look up here in this little box up here, if I give you 3/5 times 1/6, the 3 and the 6 can cancel out because they have a common factor of 3. Okay, we're going to be multiplying here. We're always multiplying. Think about that. We always multiply inside these conversions. Okay, so I actually cancel these out just like I did up here. I cancel my years out because they have a common label of years, and I will get, multiplying straight across, I get 500 pounds in 12 months. 500 pounds in 12 months. Okay, so now when I do this problem, I end with a rate like this. But I don't want it in 12 months because that's technically 1 year. I wanted it per month. So what I have to do is take 580 divided by 12, and I'm rounding to the nearest hundredth, or sorry, rounding to the nearest tenth. My answer is 48.3 pounds per month. Okay, 448.3 pounds per month. All I did, again, I changed years to months. Years to months. All right? All right. All right, so here's a tricky one that, again, we're going to do together. It says a train traveled 180 miles on a railroad track in 4 hours. How many feet per second was the mile traveling? Well, looking at this, what's the very first thing that I'm dealing with? What is that rate, that first rate I'm dealing with? Well, I'm dealing with 180 miles in 4 hours. Mr. Schumann, your handwriting is ugly. I know. Don't worry about it. Okay, so as you look at this, 180 miles in 4 hours. One thing that we need to do is the very first thing we need to change. Let's get rid of our hours. Okay, let's get rid of our hours and make this easy. So if I do this, I'm going to change hours to seconds. Hours to seconds. Now, with this problem, all right, sometimes I can't always directly change hours to seconds because that might not be the quickest thing to know in your brain. So is there a unit between hours and seconds? Yes. What is that unit between hours and seconds? Minutes. Okay, so now it's easy for me to change hours to minutes and then minutes to seconds. Does that make sense? Hours to minutes, then minutes to seconds, because we know those rates. Okay, so I know that there is 1 hour. Sorry, in 1 hour there are 60 minutes. Good TV show. Then, inside 1 minute, there is 60 seconds. Okay, so first I changed hours to minutes, and then I changed minutes to seconds. One thing that you will notice here, okay, again, why it's set up as hours to minutes and minutes to seconds here. Again, this is hours to minutes, and this would be minutes to seconds. Okay, and the reason why I do that is because look at your labels. Look what I can cross off, what I can cancel. If I look at this, if I cross here, hours cancels with hours. All right, see that? See how they simplify out? They cancel each other out. Also, minutes cancels with minutes. All right, because I have a numerator and I have a denominator, just like a fraction. Hours and hours cancel, minutes and minutes cancel, and I'm left with my unit of time is in seconds. And that's exactly, if you notice what's here, I want it per second. Well, right now, I got rid of all of my units of time except for seconds because they have a common label. There's a numerator and there's a denominator, just like when we multiply fractions. One's a numerator, one's a denominator. If they have a common label, I can cross them off. Now what I'm left with is I need to change my miles to feet. And this is where it gets a little confusing because you want to change miles into feet. Miles into feet. But if I put miles on top and feet on bottom, notice I have miles on top over here, and I want to get rid of that. I cannot cancel out this miles when this one is also on top. Because if I took miles times, if I multiplied straight across on top, I would get miles times miles. Okay, does that make sense? I get miles times miles. So I cannot use this miles on top when in fact, because it is on top to begin with, in my numerator, I keep saying it on top, because it's in my numerator on top, my answer, I want to have miles on bottom, because then, and feet on top, and feet in my numerator, because then I can cancel these two out. Okay, I can simplify those two labels because both of them have the same label. So I can cancel those two out. And if you don't know, there are 5,280 feet per mile. So I'm changing my feet or my miles into feet, but I need to make sure that my miles is on bottom because of the way it's set up in the beginning. If you look at your labels here, notice this is crossed off, this is crossed off, this is crossed off. What I'm left with is feet on top. My unit would be feet. On the bottom, this is crossed off, this is crossed off, and this is crossed off, and I'm left with my denominator label is going to be seconds. Notice that? My denominator label is seconds. So if I were to do this problem, okay, because now I have to take 180 times 5,280. 180 times 5,280. Because those are my numbers on top. 180, 5,280. Notice I'm multiplying everything to. I could take 180 times 1 times 1 times 5, 5,280. But again, I'd get the same answer. So what I get is I multiply straight across 950,400 on top. And on bottom, I need to take 4 times 60 times 60. And when you multiply all of those together, you will get 14,400. Now, so that means 950,400 feet, it will take me 14,400 seconds. Now, these are big numbers. I don't want to deal with these big numbers. I want to get it in feet per second. I want that bottom number to be 1, remember. So I take 950,400 divided by 14,400, and my answer is going to be 66 feet in 1 second. So I did all of that work, okay, to come up with 66 feet in 1 second. Aren't you glad that we can now use a calculator? It's a wonderful thing. Otherwise, that might take a little bit. All right? So 66 feet per second. Let your labels tell you where to go. If 1 is in the numerator, again, like miles. Miles was in my numerator, so in my next problem, in order to cancel out miles, because miles is in my numerator, I need to come up with a rate where miles is in my denominator. Okay? So let your labels do the talking a little bit. Alright, here we go. It says a strobe light can be used to measure the speed of an object. The lamp flashes every 1/100th of a second. A camera records the object moving 52 centimeters between flashes. So it's recording the object moving 52 centimeters between the flashes. Okay? How fast is the object moving in meters per second? So I need to change this, and it's centimeters here per 1/100th of a second. That's what's going on. centimeters per 1/100th of a second. Okay? So I need to change that into meters per second. So let's start off with a ratio here. Let's start off with, or sorry, not a ratio, a rate. A rate. So as you look at this, okay, when we set up this problem, we are going to get 52 centimeters per 1/100th of a second. Okay? Now, one thing that, if you notice this 1/100th of a second, man, that is ugly as a denominator. It's a complex fraction. I don't like complex fractions. So let's change this into 1 second. How could I change 1/100th of a second into 1 second? Well, multiply by 100. If it flashes 100 times, okay, 100 times, how many seconds has passed? 1. Okay, so what I'm going to do is I'm going to get a common denominator, or not a common denominator, but just an easy denominator by multiplying each of these by 100. Okay, so my answer here would be 52 centimeters times 100, which is 5,200 centimeters in 1 second. Okay, because I changed that 1/100th of a second just to 1 second. It makes it easier to work with, and it makes it nice to work with. Instead of working with 1/100th of a second, I'm dealing with just 1 second. All right, so in 1 second, something can go 5,200 centimeters. All right. So as I look at this, now I need to change this 5,200 centimeters per second into meters per second. Do I need to change my seconds at all? No, I don't. But I need to change centimeters into meters. Okay, so think about that. I need to change my centimeters into meters. But think about what my next fraction is going to be. Where do I need to put my label? That's what I want you to think about. Where do you put your labels? And there's going to be, in every meter, there is 100 centimeters. I will say that one more time. In every meter, there is 100 centimeters. 1 meter equals 100 centimeters. So I want you to see if you can figure out where your labels go. Set it up just like this. Okay, where would you put your labels? Where would you put your numbers? What would your answer be? So pause now, try this one out. All right, so as I look at this, I want to get rid of centimeters right there, which is in my numerator. So I'm going to put centimeters in my denominator. Okay, why? Because then they will cancel out. So if centimeters is in my denominator, that means meters is in my numerator. Now I just fill in the numbers. 1 meter is equal to 100 centimeters. Okay, these two cross out. When I multiply straight across, I get 5,200 centimeters over 100 seconds. When I simplify this as much as possible, I get 52, sorry, not centimeters. Mr. Shee, what are you doing? It's meters here. So there's 5,200 meters in 100 seconds. As I multiply straight across, I get 52 meters per second. So that object is moving at 52 meters per second. Okay, that's all I have for you today. This, and I understand this. This is can be a confusing lesson. We will talk a little bit more about this tomorrow if you have any questions. But now you have that little seed planted in your brain after you watch this. Okay, all right. Have a wonderful day. I will see you tomorrow. Bye.